Okay, well, it's 10 o'clock, so we can go ahead and get started. Thank you all for joining us for another edition of the Long Coffee Break. My name is Bill Ronan. I'm a senior sales engineer with Long, and today we are going to talk about Oxygen 8 energy recovery ventilation. We are lucky enough to be joined by Todd Fall, Director of Sales with Oxygen 8. Thanks, Todd. With that, I'll hand it over to you.
Great, thanks, Bill. I appreciate the opportunity to discuss this with you today. At Oxygen 8, we help create healthy spaces through improved indoor air quality utilizing energy efficient ventilation technologies. And in particular, we're going to talk about ventilation and how we can incorporate that in with the electrification movement that's going on today, looking at energy recovery and 100% split outside air DOAS units, in particular, how it affects cold climates. So if we look at past designs to bring outside air or ventilation air into the building, we typically use package units located on the roof, whether that had 100% outside air or a combination of outside return air. You use DX cooling for that side of things. And then on the heating side, you typically had a gas-fired heating element. Very simple, tons of installations around North America. As we move to electrification and decarbonization, we can no longer use the gas element for doing the heating. So we have to find ways of accomplishing this in other ways, particularly in cold climates. So what do we do now that we need electrification in cold climates such as Denver? Very simple way is to provide electric heat, strip heater that goes into the ductwork or into the outside air or mixed air stream to heat that air temperature up. However, these electric strip heaters can utilize a tremendous amount of energy when we're trying to heat air from 0 degrees up to, say, 70, 80 degrees or even higher. A more efficient way to do this is to utilize heat pump technology. So heat pumps are inherently more efficient. However, they tend to reduce in capacity as your outside air drops. Heat pump technology is definitely getting better, and we can see improvements all the time. You'll probably see that if you're going to AHR this year, of a lot of improvements there. But a lot of the times, because we have this reduced capacity at low outside air temperatures, we can't get the delta T across that heat exchanger. We can't get the rise of the outside air temperature that we're looking for. So a lot of times we have to add in some supplemental heat strip heaters, which again sort of reduces the overall efficiencies of heat pumps. So how do we help out the energy efficiency of heat pumps? One easy way to do that, a great energy efficient way to do that, is to raise the entering air temperature going into that heat exchanger so the heat pumps and the compressors don't have to do as much work. So we can do that with readily available air-to-air heat exchangers. So these are very simple devices where we're just transferring energy from one airstream to the other. In this example here, we're taking the relatively warm space air temperatures of 70 degrees and transferring that to your 0 degree outside air temperatures. So these are very efficient. It's not uncommon to see supply air temperatures coming off the heat exchangers in the upper 40s to low 50s. So what that does for us is now it's much, much easier to further heat that outside air in cold temperatures. So now we've got 50 degree air. We can utilize hot water coils, VRV, DX, heat pump coils, electric coils to further raise the temperature of that air. So again, we're just improving the overall efficiency of the system. Today, we're going to be talking about plate heat exchangers as opposed to rotary heat exchangers. Plate heat exchangers have a couple of advantages. One is there's no moving parts. So we have added maintenance of not having belt shifts, bearings, external variable frequency drives to worry about that might have a failure, and now we have to size our heating system to account for a failure. With plate heat exchangers, extremely reliable in that regard. Also allows us to have a low profile as we put these into air handling units and be able to put into very tight spaces, up into ceilings and walls, which you'll see there, which helps to take advantage of decarbonization. But when we look at heat exchangers, there's basically two flavors. There's HRV, which is heat recovery device, and an ERV, which is an energy or enthalpy recovery device. For HRVs, basically they are just parallel sheets of aluminum plates that go the length of your core, and they transfer sensible temperature or sensible energy only. So only temperature gets transferred, no moisture gets transferred. You may think in a dry climate like you have in Denver, you may not need moisture transfer. They are very efficient at transferring sensible temperature. However, with cores, you have to worry about frosting in the wintertime. So the frosting occurs when your return air starts to freeze In a HRV, that temperature typically starts to show frosting around 28, 29 degrees. So we need to have a preheater. So we have a preheater electrical device to bump the air up from 0 degrees up to 30 degrees, say, and anytime the air temperature is below that, we need to run it. So it does add to now energy that we're trying to avoid and putting in with these energy recovery systems. The ERVs are total enthalpy recovery. These use a polymer membrane, at least the newer versions of these use a polymer membrane, where we have, again, these layers of basically a thick plastic, if you will, that now transfers not only temperature sensible, but it also transfers the latent energy. So a benefit of that in cold climates is now our core frosts at lower outside air temperatures. So we typically see frosting not occurring until the outside air temperature is around 0 degrees or 5 degrees. In fact, if you're building RH in that design day of 0 degrees outside is 20 or 25% relative humidity, we probably would not need any type of preheater at all. So it makes for a much more energy overall system. And this polymer membrane, it's a pretty unique material. It's kind of like a thick plastic or a thick saran wrap that has a substrate applied to one side of it. That substrate is specifically formulated to only pass through a water vapor molecule. So it won't pass through any VOCs, any PM 2.5s, any odors, any viruses. So it does make for a nice material that has zero cross-contamination. So we do have total separation of your exhaust air and your outside air, which is a lot of times favorable, where we don't want to have any recirculation of the exhaust air that we're trying to get out of the building. So to visualize how these can work, again, putting these up into ceilings, small closets, small mechanical rooms. Now we can have units that maybe serve an individual classroom or conference areas that we can turn off when that space is unoccupied instead of waiting for the whole building to go unoccupied. So there's a lot of energy and controllability advantages to this. At Oxygenate, we have a lot of different solutions. Out there on the left is cross-flow core. So these cores have been around for decades now. Basically, you have airflows that are parallel in the same direction that cross as they go through the core. And this gets you your standard ASHRAE 90.1, 50 to 55% total energy recovery. In the middle there, we have a newer design. This is called a counterflow core. So starting to see this more in North America, where now we have parallel airstreams, but they are opposite in direction. So I have a large delta T across the heat exchanger, and that gets me energy efficiencies of 70 to 75% total energy. We also have the ability to just do a straight makeup air unit. So if you have a separated exhaust system, you just want to bring outside air in, we can further heat, cool, and dehumidify that through this unit here. Typically see that in dormitories, hotels, restaurants, really any area where you have this sort of separated exhaust. All of our units share some commonalities. So they all have double wall foam injected panels, so there's no insulation in the airstream. We have MERV 13 filters on the outside air, which is the recommended filtration requirements. We use ECM fans as standard, so reduced moving parts, very low noise and vibration, very energy efficient, can do variable air volume or constant air volume as standard, and easy to commission as well to adjust for any ductwork changes from your schedule. And everything comes with standard Distech DDC controls to make for a package plug and play solution. This is an example of just taking advantage of some of the flexibility that you can have when you do decentralized ventilation. So here we had a mechanical room that didn't have a lot of floor space, but did have a high ceiling height. So we were able to put an ERV up against the wall. You see there, the air comes out and does a 90-degree, and we actually put the heating element, or this case, it was a hot water coil, actually below the unit. So again, just taking advantage of the space constraints that we have to give the designers a lot more flexibility in how they're designing buildings. This is an example of some flexible duct connections that we can do. So we can optimize ductwork, fit these units through small hallways, down stairways, through doors, through elevators. Gives you, again, a lot of flexibility of where you place your ventilation solution into buildings. And it's an example of a coil module that's up and out of the space. And here we're using a heat pump, a VRV heat pump that's doing the heating and cooling of the outside air, and then an SCR controlled strip heater, electric heater, to do some trim heating, dehumidification, or backup heating. But again, probably would not have been able to fit a total package unit into this small spaces. It's actually down in a basement in a project in Iowa. We can also fully integrate into a Daikin VRV system. So this is showing you how we can do a heat pump and a heat recovery outdoor unit to do heating, cooling, and dehumidification all at the same time to get you very tight leaving air temperatures at room neutral condition with temperature and humidity levels. Everything you see there is a factory package. Even the stuff you can't see there is factory packaged at our factory. So the controllers that control the Daikin electronic expansion valves, those get mounted at the factory and wired. The electronic expansion valves are factory mounted, brazed to the coil and wired. And then everything, all of that gets connected back to our DDC controller. So we have a very simple, quick installation for the contractor. They just have to bring power to it and connect up their piping to the rest of the VRV system. So very simple solution. We also have products that can integrate all these different accessories into a common footprint. We utilize, again, this high efficiency counterflow cores and a stacked matrix arrangement, and that can allow us to get airflows up to 10,000 CFM or more. So we have fan filter modules. Of course, we have our ERV or HRV core modules in there as well. And then we can add these modules as needed per the project requirements or design requirements. We can add preheat if you need it. We can add post heating and cooling utilizing hydronic, DX, VRV systems. We can even integrate in recirculation. So we don't have to be just 100% outside air. We can recirculate and do a lot more of the comfort cooling that's required in the space. Also allows us to do some specialized filtration and even take advantage of IAQP solutions as well. Just another example of a factory package solution there. You can see the controls there on the left through these access doors. We've got in this solution, you can see there's coil stub out connections, either hydronic or DX or VRV. There's an example of just how we mount and factory wire, braze, all of the components that we required for a VRV system as well. So again, nice plug and play solution. And then an example of just using 100% outside air. So this would utilize a Daikin VRV where we have the controller, the EKXV, the expansion valves installed in there. And then we have room neutral condition at 70 degrees, 50% RH that's fed into, in this particular example, into the VRV cassettes, or we could put it directly into the space via diffusers or backup fan coils, air handlers, whatever is needed. So just kind of do a recovery of or recap of what kind of advantages you can get. So an example of a 2200 CFM ventilation requirement for a building, just brute force. So reducing that 95-degree air in the summertime down to 55 degrees or heating from 0 to 85 degrees. Some sort of system in your building is going to have to do that with your ventilation air. So just that 2200 CFM is going to take about 100 MBH on the cooling side and 150 MBH on the heating side to be accounted for. If we just use a standard efficiency core, we can reduce that cooling load by 20% and the heating load by 40%. And then again, using our high efficiency counterflow cores, now we're reducing your cooling load by 30% and your heating load by 50%. So again, reduce the first cost of the building. We don't have to deal with the amount of outside air load that we typically would have. And obviously the smaller equipment also runs more efficiently over time. So in recap, ventilation with electrification requires some different approaches, especially in cold climates that we kind of looked at. ERV does become really important to provide a more energy efficient system when you're looking at electrifying and heat pump operation. And of course, long and oxygenate, we have numerous solutions for you for any of your ventilation needs. So with that, please feel free to contact your local long sales rep to set up a meeting, or you can contact me if you had any questions, particularly about today. But with that, I will hand it back over to Bill.
Thanks, Todd. I really appreciate it. Thank you all for joining us on this coffee break. Please reach out to your long sales engineer for additional information on oxygenate energy recovery ventilation. And now it's time for giving out prizes. This week's prize choices are Sephora $100 gift card, Spa Finder $100 gift card, and a Top Golf $100 gift card. And thanks again for joining us. Have a great day.